So let's quickly get into the demo to have a closer look on how these things like process discovery, flow and bottleneck analysis, and simulation work in more detail. And of course, how they can be placed into the wider context of intelligent automation. In this case, we're going to upload a CSV file. But as you can see, we support many more extensions. MXML, Parquet, XES, just to name a few of them. So to upload the file, I'll click on Browse, and in this case we're going to upload a claims management file, which could easily come from a system like Guidewire, for example. I double click on the file, click OK, and then it says we've already done a mapping like this. Do you want to reuse that mapping? And yes, let's reuse the mapping we already did. Now, to do process discovery, we need at least 3 attributes. And the first of them is a case ID. So we need to follow something like a purchase order or an invoice, or in this case, a claim in the application itself. So we connect the case ID column with the case ID in the log file. And then we need an activity on that case. So you can see here all kinds of activities related to a claim, like register a claim, quick assessment, approvals, all kinds of things that are related to a claim and maybe change the state of the object that we're following. And we have to map that column to the activity in the log file. And then to discover the process as well, we need at least an end timestamp, and we see here that the complete timestamp, we've mapped that to the end timestamp in the log file. But we have additional attributes that we can map as well. So as you can see here, we can also add a start timestamp, so we know when the activity starts. We can also map a resource, right? And as you can see here, I can obfuscate that resource or anonymize it, as it says here. But just for demo purposes, we leave the names of the resources in the file as they are. And then I can identify some additional event attributes and case attributes in the file. Once I've finished mapping the file, I click Upload Log. I give the file a name, claims management in this case, and click OK. Now the system tells me how many events are uploaded. I click OK, and I can see here in my directory claims management, the claims management log file is uploaded. I can now go 2 ways. I can go and do an investigation by double clicking on the claims management log file, but I can also go already to the reporting part of the claims investigation and all the dashboards that are automatically built as well. So let's double click on claims management, and we can see here that the process is actually discovered and is laid out on the canvas here. Let me make that a bit bigger. We can pull these different activities around and we can play around with this process. Now, like I said earlier, what we're basically doing is we are discovering the process, we model the process / enhance the process, and we can simulate the process. And you can see here I've got some visualization settings that I can use, and I've got some abstraction settings that I can use, right? So looking at the arcs are really the transitions between the different activities here. You can see the arrows, right? And when I use the slider, what happens is I get more transitions available on the canvas here. I can now start looking at the different frequencies that some of these activities are actually executed. And you can see here in the visualization settings, using the overlay of frequency, which has a blue color, that register claim is activated 608 times. Now, as we uploaded 608 cases, it means that register claim is used in all the cases that we execute. Now, as you can see here, there's a color coding as well. So the darker the color, blue in this case, the more times the activity is actually executed in a case. And as you can see, we can now, through the color coding, follow the happy path of the process all the way back to the end. Now what we see as well is that there are some things happening here, right? We can identify loops, for example, where a loop takes place or activities are transitioning to an earlier part in the process. Or we can identify, and we can see this here on this line, where is the process left? So we're leaving the process at analyze claim. We're also leaving the process at close assessment. We're doing that 131 times. We're also leaving the process in improve assessment and finalize assessment. What we also see is that there's a correlation between close assessment and amend assessment. This is what we call a ping-pong relationship. We go from one activity and then back to the same activity multiple times. So we identified a ping-pong loop. Also, what can happen here is that we have a self loop where the activity verify claim is executed multiple times in a row within certain cases. So what we can see here quickly is where do we have these loops and where do we need to make sure that if we are in an automation environment, where to start and how to help our customers. A good setting in the overlay is not only frequency with the case numbers, but we can have a look at the maximum as well. When we switch to max, we can see how many times this particular loop is performed in a singular case. This is what we call rework. I can now set my SLAs on top of the case as well, or on top of the process. I can easily do that by using a filter. And in this case, I'm using the rework filter, and I'm finding, by organizing this and sorting this, the amend assessment activity. And I can now say that we don't want any cases where this happens more than 5 times. And as you can see here, I put in more than 5 times and I'm retaining those cases. I can also remove those cases if I don't want to see them. And I can now see that 2.8% of the cases, 17 in this case, follow this particular loop more than 5 times. And I can easily go back to the application and have a look which of these cases adhere to this particular filter. And I can click on that and then follow each of the steps that are taken once I look at a particular case. So this is how to identify how the process flows, where do I have improvement opportunities related to rework and process flow. I can easily switch to the overlay duration. And when I look at the overlay duration, the color coding on the process is changing to red. And visually I can now see through the darkness of the color which of these activities takes the longest to perform. And you can easily see that verify claim by far takes the longest to perform. This is the identification of a bottleneck based on cycle time, right? So this could be one of the activities that we could use for automation. But we can see finalize assessment is taking a long time as well. Now this color coding doesn't only work for the activities itself, but it also works for the transitions between the activities. And this means that the thicker the line, the darker the arrow between the activities from one activity to the other, the longer it takes to make that transition. And when we have multiple incoming transitions that take a long time, as you can see here for close assessment, there is a bottleneck as well. This bottleneck is not related to the actual execution time, because you can see close assessment doesn't really take that long, but it is related to the waiting time. It's related to the amount of work that the resource or the resources performing this task have to do and not having enough time. So the work is bubbling up in front of the close assessment activity, and we call this dynamic wait time. And if you want to see what resources are actually involved in the close assessment activity, you can easily slice and dice that type of information. And we do this using shortcut keys in this case, but you can also do this by using the filters again. So if I delete the filter that I created before, and I'm looking at 608 cases again, you can see close assessment, Control Option right click, and I sliced the whole process, and I focus now on this particular close assessment activity. And whilst looking at that, I can easily switch perspective. I can now look at resources. So which resources are actually performing that task? And you can see here Francois, Carol and Magdalena are actually the ones performing that particular task. Or I can see what role are they in. So they are in the role of claims officer, and they use the system Guidewire Claim Center to do their work. And again, switching back to resources in this case, and getting rid of the previous filter, you can see the handovers between all the users, right? And you can see that can become very complex. So let me tone it down a little bit. And now we can easily see who is performing the most tasks in the most cases. And you can see Carol, Francois, Marcello, and Marlon are pretty busy. And we see Magdalena here as well. So again, this is the number of tasks that they're actually performing. And again, I can do the same here when I'm looking at duration. I can switch to how long it takes to do that tasks. So I'm not looking at a process in the form of an activity, but I'm actually looking at a resource and the average duration they spent on the different tasks. And there you can see who take the longest, right? And you can see here Carmen and Esmeralda take the longest. But again, it's not only how long a particular task or a particular resource takes in this case, but it's also the lines in between. So how long does it take to hand over from one role, from one resource to another? And you can see here that Francois, the handovers between the different resources take a long time. The same for Magdalena, right? And the same for Carol. And this makes sense because these were the resources working on the particular task that had the resource utilization problem. Now, handovers are an important part in deciding which of the activities are important to automate. And that's not only handovers between resources, but it could also be handovers between systems, for example, where we could have a closer look at how many times do we have these handovers and what do we actually perform when we do these handovers, right? And can we assist the resource while performing their activities while they're switching between different systems, for example. So far we uploaded the log file, we discovered the process, we did some flow analysis, we discovered rework. We had a look at bottlenecks, not only for the process, but also for resources and even roles, maybe different business units and systems. We had a look at the handovers and resource utilization. Next thing we can have a look at is how can we then document that process and then use that process for what-if scenarios. Back at the discovered claims process. So here we can use the arc slider to decide how much complexity we want in our claims management process. Once we found the right complexity, the right number of nodes and transitions that we want in our process, we can use the view switch to switch from process map from the flow chart to a BPMN model. The BPMN model will give us all the gateways that we need. We can discover OR gateways, XOR gateways, and AND gateways. Once we're happy with that, we can switch back to the process map and save that as a BPMN file, right? So here it says save BPMN model, the name of the model, let's leave it at claims management. We click OK, and then when we go back to the portal, we'll see that we have a new file created. It's claims management, and this is a BPMN process that we can model out and enhance any way we want. So the discovered process is given to us the way we saw earlier in the process discoverer. We can at least make this a little bigger so we can read what's going on. And from here we can start changing the process and making sure that we've got everything we need. Maybe add some manual steps, for example, if needed. This is a fully fledged BPMN editor that you can use to enhance the process any way you want. When the enhancements of the process is finished, it looks like this. You can see we added the roles as swim lanes in a pool. This just makes the whole process a little bit more readable. From here on, we added the simulation parameters. How many cases will arrive in a certain period of time, and how many cases would you have in a certain period of time. We define the tasks and the resources that are performing the tasks. And for each task, we define a distribution, whether that's fixed or any other distribution that we can choose from, like normal or exponential. We also give it a value in time, the number of minutes it takes to execute a particular task. And we do this for each task in the process. Once that is done, we define the timetables. The timetables may be for different roles, they work different hours. Or we can just define the office hours that we are all working against from Monday to Friday from 9 to 5. Next, we define the resources. So all the resources that we use in our process, we define which timetable they use, how long do they work, and we define the number of resources that we have and the cost per hour. And last, we define the gateways. So we do that in the way of a percentage. So for each gateway with more than one outgoing transition, we define the percentage of going to one way or the other. As you can see here, 96% goes to assess claim and 4% goes to amend claim. Once we have done that, we save the file, and this could be our as is process. So I define this as claims management as is. I can now go back to the portal, look at my file, claims management as is, and now I can run a simulation model. I run that on the process that I just defined. I give that a log name, and I define that as is at the end, and you can see that log will define here. So what I can do now is double click this, and I can do the same kind of analysis that I did before, and you can see it's pretty much looks and feels the same. We got bottlenecks on verify claim, we got some resource utilization issues on close assessment. So for us, the log file is always first class citizen. But what I can also do is now go straight into the performance dashboard and have a look at my simulation scenario in a matter of case duration. How long does it take? But I can now also see the cost. So on average, it takes about $58 to run one instance of the process. And furthermore, I can have a look at the resource utilization. And I can see that the product manager is overutilized. So normally around 90% utilization, you start talking about overutilizing. And we will see that the product manager actually performs one of the tasks that we're going to change in the next process that we see here. So what we're going to do here is create a to-be process. So where the product manager performs verify claim, as you can see here, which was one of the longest running tasks that we identified when we had a look at the bottlenecks, we put next to the product manager a verification bot. So what we found is to do the verification of the claim, the project manager needed a lot of information, and a lot of this information came out of different systems. So what the bot's doing, it's gathering all the information for the product manager to quickly verify the claim with all the information at hand. Now once we change the process and we've defined this as a to-be scenario, we save this as well, and then we go back to that particular process and analyze that the same way with the view performance dashboard with the simulate model. I do the same thing. I extend this with a to be, and you can see it is creating now a new log file. What I can do now is compare the two simulation runs that I did. So I can select this log and the to be log and then have a look at my performance. And what you can see here is that it's putting the two cases next to each other. So I can now have a look if the implementation of the bot will be successful before I actually implement the bot. So this can save me a lot of money. Now first of all, we have a look at cycle time. So we went from 2.89 weeks to 1.39 weeks. So that's a tick. Then we can have a look at cost. So we went to an average cost of $858 to an average cost of $390 per process instance. So that's a tick as well. Now the last thing we need to check, of course, is our resources. And when we look at product manager, which was in the as is scenario utilized for 98%, we can see that the product manager is now only utilized for 23%. So that's a tick as well. But the funny things with bottlenecks is that you solve the one and you will create the other, or maybe you will create another bottleneck. And you can see here that we're sort of creating another bottleneck with the claims manager, because there are so many cases coming through that further down the process, the claims manager comes into trouble because it doesn't have enough resources to perform the job.